Okay, so today I want to try to answer a question which has come up on several past year papers in the last few years, which is when does a function have an inverse, or explain why a function does have an inverse. So in order to do that, really, we need to first go back and understand mappings. There are three different types: one-to-one, many-to-one, and one-to-many. We're going to try to explain those quickly now. So a one-to-one mapping, for example, x gets mapped onto x plus 5, is called one-to-one because each input gets mapped onto one and only one output, right? So the input -2 is mapped onto 3. That's the only input that goes onto that output. Okay, so one input corresponds to one and only one output, hence we call it 1-to-1, one input to one output. And what would that look like on a graph? Well, let's say we've got the input 2. The input 2 there is mapped onto one output, 7, and only one output, right? So it's a one-to-one mapping. What about a many-to-one, such as x gets mapped onto x squared? Well, here let's say we've got the input -1. That gets mapped onto +1. But so does the input +1, right? That also gets mapped on to +1. So what have we got here? We have got two potential inputs that gets mapped onto one output, right? The same output. So we've got many inputs that go to one output. And so we call this many-to-one. And what would that look like on a graph? Well, let's say we were to take our input +2. Okay, if we were to go up to there, that gives us an output of 4, but also the output of 4 could have been achieved with the input -2, right? So again, what we see is on the graph that there are two inputs that give us the same output, in this case 4. All right, then what about one-to-many, the last one? Well, we could think about the mapping x goes to the square root of x. Now, in this case, let's take the input 1. The input 1 could get mapped onto -1 as well as +1. So what do we got here? We've got one input that gets mapped onto two outputs, right? So one input mapped onto many outputs, and so we call this a one-to-many mapping. And what's that going to look like on our graph? Well, let's say we were to take the input 4. That would get mapped onto +2 as well as -2. So we've got one input that goes to many, in this case, two outputs. Now then, what's the key fact that you need to take away in order to answer the question? The key fact is this: a one-to-many mapping is not a function, right? A one-to-many mapping is not a function. One-to-one is a function, many-to-one is a function, but a one-to-many is not a function. And the question is, why? Why is that the case? Well, I think probably the best way to explain it is to use the example of a computer or like a smartphone or digital device. Okay, so let's say that you've got your smartphone and you touch your smartphone because you want to accomplish something. Let's say you want to open up your web browser. When you're doing that, what you're actually doing is you're running several different functions, right? So the first function is your smartphone is going to detect the coordinates of where you're touching on the screen, right? So the first function is finding the coordinates of your touch input. The second function might be to identify the action that those coordinates refer to, right? So if you press the part of your screen where the app is that you want to open, right, then the phone needs to understand that what you're trying to do is to open that app. Okay, and then the third function would be to actually execute the action that you want, in this case, opening an app or opening your browser, whatever it is, right? So there are three different functions. And what's happening here is all the functions are leading into each other, right? So I touch the screen, I get a coordinate here, whatever it is, like 30,253, right? That coordinate gets fed into the next one, identifies the action, and that action is open app, right? Let's say that's that. And then the final action, the execute, is actually opening up the app. Now then, why does this mean that a one-to-many mapping is not a function? Well, because basically, if we've got many possible outputs for the same input, then we're going to have a problem. So let's take this middle function here, the identify action, right? We've got a particular coordinate, let's say 3253, and we're putting it into that function. We want to identify what that coordinate refers to. Well, let's say that we had two potential actions. One is opening the app, and the other action is, let's say, closing the app, right? We've got two competing outputs. Now, actually, the issue of them being competing outputs is not really so much the problem. The issue is more that if you've got two outputs, the computer doesn't know how to choose. It doesn't know how to decide, right? Computers are not built to make decisions. And so if you've got a situation where the function's got two potential outcomes, the computer or your smartphone doesn't really know what to do, right? Which of these should be input into the remaining function? Okay, so essentially what we've got is we want to avoid the situation where any function has got many equally plausible outcomes. Okay, you only want to have one and only one output for a function. Okay, so we end up with this conclusion: one-to-many mapping is not a function, right? That is the key thing. All right, then, well, let's return to the initial question, which is, when does a function have an inverse? Okay, well, then to answer that, we need to just quickly think again about what an inverse function actually is. So what is an inverse function? Well, an inverse function looks something like this. Its job is to undo the operation of the original function. So, for example, let's say I had an input to my function, which was 3, and my output was, let's say, 7, then what we're saying is that if I was to take 7 and put it as an input to my inverse function, then what I should get is I should get back to 3, right? So that the whole job of an inverse function is to reverse the output back to the input, okay? All right, then. Well, if that's the case, if we've got a function which is a one-to-one, one input to one output, and we reverse the inputs and outputs, then what we're going to get is we're going to get a one-to-one. Okay, now just think about that again, right? What this means is we've got one input to the function f that gives us one and only one output. Then if we were to reverse that, we would have one input to the inverse function, which gives us one output for the inverse function, right? So a one-to-one, if we switch it, will just become one-to-one. But then what about a many-to-one mapping, right? If I've got a many-to-one mapping and I invert it, if I switch the inputs and the outputs, then what I'm going to end up with is a one-to-many, right? So let's think about this. So I've got many inputs that go to one output and I invert it. That means I've got one input to my inverse function, which gives me many outputs to that inverse function, right? So a many-to-one mapping inverts to become one-to-many. What we said a moment ago is that a one-to-many mapping is not a function. Okay, so that's the key thing there. A many-to-one cannot be inverted, because if we invert it, if we switch the inputs and the outputs, we're going to get a one-to-many, and a one-to-many is not a function by definition. Okay? All right, then. So, when does a function have an inverse? Well, it can't be when it is many-to-one, so it must be when it is one-to-one only. Okay? So when does a function have an inverse? When it is one-to-one. Now let's try to visualize that with a graph. So let's go back to x squared. And here we can see that this has got to be a many-to-one function, right? It's a many-to-one function because, for example, if I've got an input here, 2, that gives me an output of 4. Well, I've also got the input of -2, gives me the output of 4. So this guy is a many-to-one. And because it's a many-to-one, therefore it cannot be inverted because it is not one-to-one. But let's say we were to have a look at this function here. Now, what we've done is we've still got the function of x squared, but this time we've defined it only for x values which are greater than 1, right? So we only got x values which are greater than 1. Well, can we invert this? Yes, and the reason is because this function is a one-to-one, right? So if I imagine putting in x is 2, then I get the output of 4, and it's only that input which is going to give me the output of 4, right? There's no other input that gives me 4 in this case, right? So this guy here is a 1-to-1, and because it's a 1-to-1, it can be inverted. All right, let's try another one. Here we've got the same function of x squared, but this time we're accepting x values that are greater than -1, right? So we can have every single x value that's greater than -1. Well, can that be inverted? No. The reason it can't be inverted is because this guy is a many-to-one mapping, right? So if I take, for example, x is 1, that would map on to y is 1. But similarly, if I took -1, that would also map on to y is 1. So because this guy is a many-to-one, it cannot be inverted. Okay? So then what's the kind of the smallest value that we can get? Well, if we choose, in this case, the vertex position, right, where the graph of x squared has a line of symmetry where it can be cut into two equal halves, then that's going to be kind of the limit point for our function being a one-to-one. So this guy is a one-to-one, where we take the right-hand side of the graph. And similarly, this guy is also a one-to-one, right? This guy is a one-to-one, where we take the left-hand side of the graph, right? So usually in a question, you'll have to say what is the greatest value of x, what is the least value of x, such that the graph is invertible. What the question is really asking you is, what's the particular set of x values where this graph is a one-to-one, right? So in this case, if x is greater than 0, we take the right-hand side, and we know the function is one-to-one. If we do x is less than 0, we're taking the left-hand side, and also the function is one-to-one. Okay, so in answer to the question, when does a function have an inverse? The answer is when it is one-to-one. And so when does a function not have an inverse? When it is many-to-one. And really, the key of this for many of the questions is, how can you change a function which is many-to-one so that it can be inverted? Well, basically, you cut your function at a key point at the vertex such that it is no longer a many-to-one, but it is now a one-to-one. Okay, well, I hope that was helpful, guys. In future videos, I'm going to be going through past paper questions using this knowledge, but I hope that explanation has cleared things up for you.